Ugh, okay, alright. So now, all there's really left to do is optimize. So our variables, w1, we only add a single w variable. How we can optimize that is just gonna equal to it's gonna equal to w1, your variable, its original value. We're gonna set this to random in the beginning, so maybe it will be like 1.5 in the beginning or something. It's gonna be w1 minus a, and that's your uh, learning rate. So it's gonna be w1 minus a times the derivative of w1. And to optimize b1, and not b1, it's just gonna be b. I don't know why I said b1. So b is gonna be b minus a times the derivative of b. So yeah, we're just gonna multiply this, and then we're gonna do this over and over again. So this is in a loop. So loop. We're just gonna do this over and over again for both. And if you can visualize this in your head, when we multiply a number by learning rate, and our learning rate is gonna be set to random also. It's gonna be like 1.1 or 1.01, or sometimes even 0.001. So when we multiply 1.5, or sorry, 0.5 by 1.5, when we do that over and over again, we're obviously going to get closer and closer to 0. So yeah, we're going to get closer and closer to 0. And this is the gradient line. So when we take the derivative of two variables, that's when it's called gradient. So that's just the entire name behind gradient if you don't know much calculus. So if we're here, say, and this is our derivative of w, so currently this is our derivative of w. If we continuously multiply that by a, so it's a solid number. If you multiply that by a lower number, 0.1 times 1.5, if we keep doing that over and over again, we're going to obviously get closer and closer to 0. And we're going to get closer and closer to here. And again, if you actually did visualize it in your head, or you pop this into a calculator, when we keep doing 0.1 times 1.5, and then we sorry, when we keep doing 1.5 minus 0.1 times that number, and again this is set at random, so 0.5 or 0.1 times a random number. So let's say our derivative is 6 or something. I have no idea why it would be 6, but let's just pretend it is. So when we keep multiplying this over and over again, we're obviously going to get closer, or when we keep repeating this, we're going to obviously get closer and closer to 0, right? And since we're doing this to two variables, it's called the gradient. And since we're going down this gradient, is called gradient descent. That's literally the entire idea. And this gets our point on the gradient closer and closer to 0. And this means our cost. So our cost is actually gonna get closer and closer to 0, which is gonna allow us to make close to perfect predictions.